Hey, this is the video for 2.5, Natural Disruptions to Ecosystems. So go ahead and check out the overview and set up your guided notes. So we have different types of disruptions, and these disruptions can definitely impact an ecosystem. Some of them are periodic, where they occur at the same time every single year. For example, the wet season and the dry season. This can happen in like the savannas in Africa, and it can also happen like there could be differences in temperatures in the ocean. So one thing that can happen is migration can be impacted for different organisms. For example, in Africa, the herbivores may follow the rain patterns. In the ocean, you may have large oceanic mammals like whales will follow the warm waters for breeding and feeding. And you can also have birds following emerging insects in the spring. So when the insects are coming out of the ground, maybe they were hibernating or laying eggs. As the insects are emerging from the ground, the birds may be following them in their migration. We have episodic disruptions, and these disruptions occur on a regular basis, but they are not necessarily timed. So they occur like there is a period or a range. Like for example, there is a hurricane season. There's a forest fire season. Hurricanes will occur typically during the summer months when the water along the equator is warmer. And forest fires occur during the drier summer months and fall when the areas that they are affected have less rain. So some things that may happen is we may have seed dispersal might be impacted by these disruptions. Like for example, after a forest fire, some plants, some species of pine only release their cones when the temperature gets hot enough. So when there's a fire, these cones pop open and release their seeds, so these pine trees are able to repopulate the area. And we also have random disruptions. There's no rhyme or reason. A volcano, there's no volcano season, there's no earthquake season. This just happens periodically, randomly actually. And an example of this is ecological succession, which we will discuss in a future video, but we have either primary or secondary succession. So some of these cycles occur because of the Earth's obliquity and eccentricity. These are earth science terms. You might have to know them. I don't really know. You have to spit out these terms. But they're called Milankovitch cycles. So the obliquity is how much the Earth is tilting or wobbling on its axis. Typically it's 23.5 degrees. But sometimes it wobbles a little bit more, sometimes it wobbles a little bit less. That's going to put different parts of the planet closer to or farther away from the sun. So this can contribute to natural climate change, and also so can the eccentricity. The eccentricity is the level of circular or ovalness of the Earth's revolution around the sun. Sometimes it's a more oval revolution, sometimes it's a more circular revolution. Now we know some of these changes throughout time because we can get data from ice core samples. So basically in some of the glaciers in Greenland, down in Antarctica, they'll drill down and take out this big giant ice core sample that can go back like 500,000 years. And what they find is in these ice cores, there may be different gases, different isotopes of certain gases, different isotopes of carbon. And they can determine from these little bubbles the relative amount that was present because it gets trapped inside the ice. So what they have done is they've been able to determine, looking at an ice core, they've been able to determine concentrations of carbon dioxide in the atmosphere. And it's been pretty cyclical, and this has been linked to these Milankovitch cycles. So sometimes we're closer to the Earth, to the sun. Sometimes we are tilted a little bit more towards the sun. That's going to impact the amount of carbon dioxide in the atmosphere because it's affecting the photosynthetic rates of the plants. But also, we're able to determine the global temperature as a result as well because of, again, these bubbles are giving us indicators of different organisms that are alive during this time. And they're making these correlations because of these different, the information in the ice core sample. Now, if we put these two together, we have the temperature, we have carbon dioxide. You notice they're pretty lined up, they're not going to be perfect, obviously, because we're kind of making correlations. But you notice there's an area right here. We are way higher in carbon dioxide concentration. So whenever the carbon dioxide concentration has been high, the Earth's temperature has also been high. And this again is because we've seen specific organisms that are more prevalent during warmer climate periods. So this is basically how they're getting the information. So we have a lot of carbon dioxide, which is why we're equating carbon dioxide in the atmosphere to climate change. Now, we talked about ecosystem resilience, but we also want to talk about resistance. So if we take this basic graph over time, you may have a population that's relatively high, but then there's a dramatic event like a forest fire, for example, and the population of this organism may decrease really rapidly. And then the amount of time, it's going to take a little while for that population to rebound. And it might not rebound exactly to where it is. This might take many, many years in order to get way back up to where it originally was. Now, the amount of impact, like population reduction, relates to the resistance. So the disturbance is going to affect this energy flow. So the resistance of an ecosystem is how bad it like falls back basically after a environmental stressor. And the resilience is how rapidly it can return back to normal. So there is what is called the natural disturbance hypothesis. And this says that in order for species diversity to be maximized, you have to have disturbances that are happening not too soon, or not too frequently, and not too infrequently. So at an average level or an average amount of disturbances, the species diversity will be very high. So if it's happening every year or every month, species diversity is going to be low because they're not going to have enough time to rebound. And if it lasts too long, they may have some organisms that are very well adapted for that particular environment, but they're not really adapted for environmental change. Now, what I would like you to do is respond to this check for understanding. And now we're going to practice the FRQ. I want you to justify which specific conditions of an ecosystem would result in high levels of resistance. I hope that this video was informative. I thank you for your attention, and I will see you soon.